Hello and welcome to episode 4, the final episode in this series about Coxeter groups. In this video, we're going to basically summarise everything that we've done so far and then investigate the different partial orderings on a real-world example of a Coxeter group. So yeah, let's get started. In episode 0, I mentioned the reflection group 442, the tiling of the plane using squares. We had a look at it, but kind of stayed on the back burner from then. We didn't really, I don't think we did at all investigate it any further. So let's have a look at it now. Okay, firstly, we will take an identity chamber. I believe this should be close enough to the same one that we used before. Okay, and let's identify some other random chamber. We'll call that A. Okay, so we've got identity here and A here. Now we can say that A can be labeled as S3, S2, S1, S2, okay, where S1 is this reflection, okay, this wall, okay, S2 is given by the reflection in this wall, and then S3, the vertical wall here. Okay, and you could go around and label each of the walls of all of the chambers on this group, on this plane, with S1, S2, or S3. Okay, and so yeah, you'll notice as well that another word that we can give for A is S2, S3, S1, S2. Okay, and that's because S2 and S3 commute. Basically, so around here, if you're here in this chamber and you go and you want to get to A, you can either do this reflection and then this one, or you can go up first and then to the right. Okay, and each of those are equivalent to doing S3 and S2 or S2 and S3 in whatever order. The other thing I'll say is that we use right hand notation, i.e. right directional. So what this means is that if you are applying this action to the identity chamber, i.e. to get to A, you apply from the right first. Okay, so first of all you do S2, then S1, then S2, then S1. Okay, so that's what's going on there. Let's have a look at the Bruhat order on the interval EA. Okay, let's have a look at the Bruhat order. So we'll put that to one side and I'll grab a fresh piece of paper. Okay, so combinatorically, we have A equals S3, S2, S1, S2. Okay. Okay. So what does the Bruhat order mean between E and A? Okay, well, it means that we are including every subword of A that contains E, that contains the identity. So that's just all the subwords. So we can write those out. Okay, there we go. So that's all. That's all well and good. That's nice, but it's a little bit abstract. It's a bit difficult to see what's going on. Okay, it's certainly in relation to 442. So let's go ahead and plot all of these. Okay, and for each of them, I'm going to use a different color to represent the different distances away. So first of all, we will have that blue represents a chamber that is one chamber away from the identity. Okay. Green represents 2. Okay. And then yellow 3 and the orange one representing 4 and also A itself. Okay. And you know, so what have we got here? Okay. Well, there's a clear, first of all, the first thing I noticed when I first did this was that there is a clear sort of spiral structure emanating from the identity. You know, you got this, and you know, and all that. And I suppose, and I would imagine that if I had chosen a chamber further out, say this one, okay, then you know I would have ended up with something, you know, a lot more, I suppose, extravagant might be a word to use. I don't know. Okay, but that's what's going on there. Okay, and another thing to note is that this spiral structure that you get includes chambers that are outside the minimal gallery. Okay, the minimal gallery being either that one or that one. Okay, you know, but because the Brouhaha order contains all subwords, you get chambers over on this side and this side as well. So you know that's quite interesting, I'd say. Okay, let's now have a look at the weak order. Okay, but on the same interval. Okay, so we'll bring that one back. Okay, so E to A under the right weak order. What does this interval look like combinatorically? Well, here we are looking for all right subwords, so suffixes of A. Okay, so what does that include? Well, first, obviously, the identity. Then we also get yeah, that's fine. That's fine. Yeah. So this is the interval that you end up with, and if we plot that, okay, let's quickly do that. Okay, so this, let's label it on the side under the right weak order. There we go. Okay, and so what do you end up with here? Well, you know, instead of the Brouhaha order type thing with the spiral of, you know, chambers going on the sort of all directions, the weak order gives you precisely the minimal galleries, the two minimal galleries between E and A. Okay, and that's because the weak order is only interested in either prefixes or suffixes, depending on which weak order you're using. Okay, and what's interesting is that this interval is precisely characterized by the reflections that enclose both E and A. And what does that mean? Well, if you take this reflection in this wall here, okay, then that has both E and A on one side, as does this one and this one and this one. So those four reflections, okay, create a subset of chambers that always includes E and A. There are others, okay, so you could take this one, but because that's not one of like the minimals, I guess, is the way you could consider it. That we don't really include that. Okay, and that is actually a proper thing. It's like a proper theorem. I don't think I prove it in my paper, but I believe it is mentioned in one of the books that is cited. So if you're interested in that, find the book, go ahead and read it. It's super interesting. Okay. Right, before we move on to the absolute order, I would like to look at the interval isomorphism property that we discussed for the weak order. Okay, so let's pick another random chamber. Okay, and we'll call that B. So let's pick this one. So this is now B here. Okay, and combinatorically, we have that so we got, first of all, we'll put A equals S3, S2, S1, S2. Okay. B equals S2, S1. Okay. So we can take the interval B to A in the right weak order. Okay, and that equals S2. Okay, so this is all the chambers. This represents all the chambers that contain B as a suffix and A and is contained in A as a suffix. Yeah, that's right, I think. Hold on, no, because we've got 2 on 2 here. So is that because 2, 1 is contained in the middle? I believe it is. Okay. Now, to be honest, it's easier to see the interval in this one. So let's actually use a completely different color. Let's go with this bright pink. So I'm going to sort of highlight each of the cells in the interval. Okay, and let's also write on the reflections that we are referring to. Okay, there we go. Okay, so let's just double check that I got those right. So B, first of all, is 1, 2, which with right hand notation would be 2, 1. Okay, then this chamber would be 1, 2, 1, which is the same in right hand notation. Then 2, 1, 2, 1. So would be 1, 2, 1. And so on. And we could 2, 1, 2, and then 2, 1, 2, 3. Yeah. So yeah, I've got all of those correct. That's fine. Okay. So what does the interval isomorphism property tell us? Well, it tells us that this interval beta A under the right weak order is isomorphic to the interval from the identity to B inverse A. Okay, now we can work out what B inverse A is. Okay, so let's do that now. Okay, so B inverse would be S1, S2. Okay, and then multiply that by A, so S3, S2, S1, S2. Now, S3 and S2 commute, so we can flip those around. Okay, and that puts the two S2s next to each other, so they cancel out. Okay, and we end up with S1, S3, S1, S2, which if we find that here, okay, that gives us, so what have we got? 1, 3, 1, 2, which in the right notation, going from right to left, 2, 1, 3, 1. So 2, 1, 3, 1 puts us up here. And because there isn't enough space, so I'm going to label that chamber C. Okay. Okay, so what can we say? We can say that this interval, equals E to S1, S3, S1, S2. Oh, that should have a sub R here. Okay. And on here, if I highlight those in purple, hopefully this purple is different enough to be noticeable on the camera. Oh, that's great, yeah. You can't see the identity anymore, but you can remember, I'm sure. So you end up with, if you work out that interval entirely, then that's what you end up with. And what that is, okay, is this interval, okay, you've sort of picked it up, rotated it 180 degrees, and then translated it left and right, left and up one, okay, to get this new interval. Okay, so the brilliantness of this, the greatness of this is that, this is a very sort of physical sort of thing that you can sort of picture what's going on. Okay, you can literally see it. And so if I had chosen any other pair of chambers, say these ones, okay, actually no, let's go with those two. Okay, then I could pick that up, okay, and move it around, and I'd end up, and I think actually you would end up with an interval starting at the identity here, going some way like that. Okay, so that's it's a nice thing. It's something that you can sort of. It is sort of quite tangible, I think. Okay, and I like that. Okay, okay. Let's now have a look at the absolute order. Okay, on the same pair of chambers. So bring a third one of these in. Okay, we will label the identity here our chamber A, and then S1, S2, and S3. Okay, you can't quite see. Okay, and what would be the absolute order? Okay, well, let's get another sheet of paper. Okay, so we've got the interval from E to A under T. So T is the set of all reflections, so that is every single one of these brown dashed lines. You have also got the brown dashed lines on the solid black ones, but because it's a physical thing, you can't quite see it because of colours and ink. Not my fault. Okay. Okay. But what that means, right? Okay, is that we have that here all of these are generators. Okay, all these dashed lines. Okay, which means that A actually equals well, the first reflection that you would do is a reflection in this one, which I'm going to call little d, this line, which would get you to this chamber. Okay, and then a reflection in this line, which I'm going to call H. Okay, and I may as well also include the reflection in this line as V, because you could go that way as well. Okay, so A equals HD, but it also equals DV. Yep. Okay. So no, hold on. Oh yeah, no, I got that right. Yeah. V first, then D. Yeah. Okay. Basically, you always have to do D, and it's just how you go from. Do you do H first, or do you do V second? No, other way round. Sorry. Do you do V first or H second? Whichever, whatever. Okay. But what that means is that this interval, E to A, actually only consists, okay, of the identity D, V, and dV. Okay, not. You might have spotted that it's not. We haven't got HD. Okay, and that's because if we plot these, okay, you'll see why. Okay, so the first one, all these that are one reflection away. So you've got that one, and you've got this chamber. Okay, and then A is next. Okay, if I did try and include H, okay, where would that put me? Well, it would put me up here. Okay, but because we are only looking at okay, I've just realised I made a mistake in my paper. You do get H as well, okay, because it doesn't matter which side you're on because the absolute order is achiral. Okay. So what you end up with, you do end up, in fact, with this chamber up here as well, which, no, hold on, which would also mean that you would need to include this diagonal. So where I had one diagonal here, I'm going to call that diagonal sub 1, and I'm going to call this one along here diagonal sub 2. Okay, and if I reflected in that straight off first, okay, I would end up with this chamber. And yes, that makes sense. That makes a lot of sense, okay, because what do you get from that? Well, if you reflect then in V, you get onto A as well, okay? So what we end up with, what is this chamber? That is D2. Okay, that is represented by D2. So 8 and then D2. Okay, yeah, that's good. Okay, that makes a lot more sense. Okay, and so what can we say about the absolute order on 442? Well, we can say that no chamber has length greater than 2. Okay, because if you think about it, what do you have? You've got you've got sort of, first of all, that diagonal one. And once you've done the diagonal, it's just a case of which horizontal or vertical reflection that you use to get to sort of get around. Okay, you can always find a diagonal reflection that is then that puts you one horizontal or vertical reflection away from your target chamber. Okay. And so I'll also say at the end of episode 3, I conjectured that there might be an interval isomorphism for the absolute order as well, like there was for the weak order. And I think that does actually also stretch to the Brouillard order. Okay, not so much in the interval sense, I guess, but I'm not sure, because no, it wouldn't work for the Brouillard order because there isn't a rotational symmetry going on there. Okay, but there is such symmetry for the absolute order. Okay, you could pick that up and sort of spin it around. And I think that if you, and so this is where that conjecture came from in my paper. This is sort of the idea that I had, that, with the weak order, you're picking things up and, shifting it around, rotating, whatever. And when I looked at this image of the absolute order, I thought, hang on, that I feel like I could pick that up and sort of spin it around and shift it along a bit, So yeah, I think there is something in it, but I haven't managed to prove it myself, and of course, as before, I invite the viewer to have a go at it. If you want to give that a try, I am not going to stop you. If you get anywhere with it, by all means, drop something in the comments. But that's it. I think that pretty much brings us to the end of this series on Coxeter groups. I hope you've enjoyed watching them as much as I've had making these videos, because like I say, I really enjoyed studying this for my master's project, okay, and I thought it would be nice to just sort of share that with people online, people on the YouTubes, on the interwebs. Okay, I thought that would be nice. I would quickly like to say thank you to David Sheard, who was my project supervisor. He did a wonderful job. He helped me so much, and also Beth Romano, who co-supervised me in the first few weeks of my project, but then afterwards David was sort of my guy, as it were. Okay, he was, like I say, he's fantastic. But yeah, there we are. That's the end. I hope you've enjoyed it. If you did, hit like, hit subscribe, do all the stuff. Okay, and I'll catch you in the next one.